going to be discussing progress that has been made over the past 10 years in validating the concept of brain energy rescue with ketones as a core component for the treatment and perhaps prevention of Alzheimer's disease. The focus will be on MCT, or medium chain triglyceride, because that is where the greatest progress with clinical trials has been made in this period. These are my disclosures. Our research is supported by public, private, and non-profit organizations. The context of my talk about MCT, ketones, and brain energy rescue is focused on Alzheimer's disease. And it's focused on a problem with brain fuel metabolism that is illustrated in these two images. The control image shows a nice distribution of the tracer fluorodeoxyglucose around the brain except in the ventricles. The areas with the arrows here in Alzheimer's disease are above the ears, and that's the parietal cortex, and this is where the problem with glucose metabolism has been apparent for over 40 years now. The magnitude of this problem starts in mild cognitive impairment with a deficit of about 10% or about 12 grams of glucose per day that's not getting into the brain that should be. As Alzheimer's disease develops, the magnitude increases, and as it gets more severe, the magnitude continues to increase with a deficit that approaches 50% of the brain's normal energy requirement coming from glucose. So the deficit increases from about 25 grams a day to about 50 grams a day, 24/7. The problem is usually apparent first in the parietal cortex and then becomes more diffuse throughout the brain afterwards. It's important to remember that the brain is like a hybrid car in terms of its fuel metabolism. So the hybrid car is cycling between gasoline and electricity and the electric motor and the battery constantly. And in the human brain, it's somewhat the same, but the dependence is more on glucose. In the adult, it's about 95% glucose dependent most of the time. It will decrease to around 70% as ketones replace glucose during periods of fasting, for instance. And in infants, it's about 30% as well, under the normal circumstance. So the brain is cycling between these two fuels. Ketone bodies, I remind you, are derived from dietary or stored fatty acids. They can also be produced from salts and esters that are now on the market. And they are converted to acetoacetate, either the product itself, the beta-hydroxybutyrate, or the fatty acid that is released from adipose tissue, converted to acetoacetate, which is in equilibrium with the D-beta-hydroxybutyrate. And there's some metabolism to acetone as well. The role of ketones in brain function was really mapped out in infants about going on 50 years ago now by people such as Hans Krebs, who received the Nobel Prize for work on the tricarboxylic acid cycle. And his group, amongst others, demonstrated that infants are normally in ketosis when they're born, in mild ketosis. It's a physiologically normal state. That those ketones are coming from principally from medium chain fatty acids in milk, mother's milk, but also from long chain fatty acids in the infant's fat stores. So mammals in general are all in ketosis at birth because they all have medium chain fatty acids in the milk. Ketone uptake by the developing brain is faster than it is in the adult, about 3 to 4 times faster. Ketone supply, as I mentioned a moment ago, about 30% of the newborn's energy requirements on a normal basis, 24 hours a day, 7 days a week. It's not a function of low food intake. It's a function of the normal needs of the brain, which cannot be met by glucose alone at birth. And ketones also supply about 90% of the carbon that's used to make the white matter that you see in the brain, the structural lipids, including cholesterol and saturated fatty acids. A couple of the key early reviews describe this in detail. So we can use what we've learned over the past half century about ketone metabolism in the infant brain and apply it to ketone metabolism in the aging brain. One of the important features of ketone metabolism in the brain is that it differs from glucose metabolism in the sense that there are two different transporters that are used, and that the driving force behind glucose uptake into the brain is the brain's activity, whereas the driving force behind ketone uptake into the brain is the blood concentration. So glucose gets pulled into the brain in relation to brain activity through the glucose transporters GLUT, several different types on the different cell types, and the ketones are pushed into the brain through the monocarboxylic acid transporter on the basis of their concentration in the blood. And this is described in some detail in our review in 2016. So the context of this problem with fuel metabolism and glucose metabolism in relation to cognitive decline is described in this circular process. Most people who work on Alzheimer's disease start with the pretext that there's a problem with the neuropathology accumulating in the brain that's contributing to cell degeneration and cell death, and this is leading to cognitive decline, and that the cell death accounts for the low brain energy, brain glucose metabolism. We see it differently. We see the problem starting with the energy metabolism and probably contributing to the neuropathology and the cognitive decline and setting up a vicious cycle that gets worse and worse. We described this in a review published this last year in Nature Reviews Drug Discovery. So the context is that there would be lower brain glucose metabolism before the cognitive decline. And the examples are shown here. Healthy older people, cognitively healthy older people, have lower brain glucose uptake than young adults. Older people with a family history of Alzheimer's disease have lower brain glucose uptake before they get cognitive decline. People with insulin resistance have lower brain glucose uptake. ApoE4 carriers have lower glucose uptake, even as young adults. And the presenilin carriers also have lower brain glucose uptake before the onset of the cognitive decline or ultimately Alzheimer's disease. So in the context of two fuels that are used by the brain, the question for us was, well, what happens to brain ketone metabolism under these circumstances? Is the uptake different, and could ketones potentially contribute to brain energy rescue? To do this research, we set up a dual tracer quantitative brain PET protocol, which we reported on a number of occasions now, in which a tracer for ketones is injected first. So we do the PET acetoacetate scan over 30 minutes. There's a washout period, so the residual radioactivity from the tracer can disappear before injecting the second tracer in the same person to study brain glucose metabolism with the tracer fluorodeoxyglucose. We also acquire a structural MRI and do functional and diffusion MRI on these individuals on the same day. We also collect blood samples to be sure that we can quantify the actual uptake of these tracers so that we can establish what the exact deficit in glucose uptake is and the potential contribution of a ketogenic substrate like medium chain triglyceride. So in summary, we've established now over a 10-year period of research that when we compare controls, healthy older controls of the same age and education to people with mild cognitive impairment or Alzheimer's disease, that the rate capacity of the brain to take up glucose, this rate constant K, decreases as you look down through these three groups. We should see a pattern with some orange in it, but broadly speaking, mostly yellow should be the present. There's a little bit of green, which is a lower uptake appearing here in the MCI, but it's especially apparent in Alzheimer's disease. So these data have been reproduced on many occasions by many different researchers in different parts of the world. What we established with the ketone PET as well is that the rate constant for ketone uptake does not decrease as you go from one group to the next. So these glucose data and these ketone data are obtained in the same people on the same day. This is a different group, but again, the same thing. This is an average scan for the ketone uptake rate constant compared to the glucose in the same people. So you can see that in Alzheimer's disease, and these circles here, there's a decline in glucose rate constant, which does not occur for brain ketone uptake. So the cells that are struggling to take up glucose here have no problem taking up brain ketones. Again, this is reported in the original paper and reviewed in our Nature Reviews review. So when we come back to the model of the hybrid car, the brain as a hybrid car, I've noted here the problem with the glucose, the magnitude of the problem with glucose uptake is on the order of 10%, and in mild early Alzheimer's disease it's on the order of 20%, whereas there's no problem with ketone metabolism in these same individuals. So this means that there's a brain energy gap, because ketones are circulating and providing maybe 5% of the energy metabolism in these individuals. But there's still a gap in the amount of glucose that should be getting in. So it's a glucose-specific problem. It starts early in MCI, but in older people we see it a little bit. It gets worse in MCI and gets even more severe in Alzheimer's disease. This gap gets worse. The question is, can the ketones contribute to reversing or correcting it? So we undertook the Benefic trial, which was reported on clinicaltrials.gov, to address this question. Could we show that there were cognitive benefits of a ketogenic supplementation, and could we show whether there's a relationship with brain ketone uptake and plasma ketones? So to do this, we have the starting evaluation that's done, and then the post-intervention evaluation that's done. In phase 1, we did the brain imaging, and we did the cognitive evaluations before and after a 6-month intervention. In phase 2, we dropped the brain imaging, and we did a metabolic study in the individuals and continued the cognitive evaluations, and then did the same thing after the trial, so in the post-intervention assessment. That 6-month period, people were either on an oral nutrition supplement, on a skim milk emulsion that contained a medium chain triglyceride, or the placebo high oleic acid sunflower oil, which was a greater than 80% oleic acid. The ketogenic MCT was about 60% C8 and 40% C10. They took 250 mils a day, half in the morning and half at supper. 39 people completed the trial on the KMCT arm, and 43 completed on the placebo arm. The participant demographics were that the placebo group and the KMCT group were quite well matched. There's no statistical difference between the male to female ratio, the presence of ApoE4 carriers, age, education, depression score, the physical activity index, or the cognitive screening tools, the Montreal Cognitive Assessment, or the mini mental state exam. The groups also did not differ in BMI, blood pressure, fasting glucose, cholesterol, triglycerides, TSH, or vitamin B12 or homocysteine. They were a mixture of amnestic and non-amnestic MCIs, which means that some of them had a memory problem, some of them didn't necessarily have a memory problem, but they all had the same level of cognitive deficit, which was mild. They were mostly able to live normal lives with this mild cognitive deficit. The results showed that when we look at the plasma ketone levels and the brain uptake of ketones, that the dose of ketones that was given in the morning had an effect on plasma ketones that did not change as the trial ended, so that 6 months after taking this ketogenic supplement twice a day, the post-treatment rise in ketones was exactly the same as it was beforehand. There was no effect of the placebo on ketones. This dosing schedule produced a twofold increase in brain ketones in the KMCT group, as you see here, and no change in ketone uptake in the plasma in the placebo group. The ketogenic MCT improved outcomes in 4 out of 5 cognitive domains. I'm showing 3 of them here, and we'll show you the 4th one in a moment. The 3 domains in which we demonstrate the results here are on episodic memory, executive function, and language. Episodic memory test was free and cued recall, in which we see that the number of words recalled did not change on placebo, so it stayed at 0, the difference in uptake in number of words, whereas the number of words recalled on the KMCT treatment was increased by 1. So 1 out of 16 words, 1 more was recalled after the study was completed. The executive function was a verbal fluency test where placebo actually declined by 1 word, and the KMCT improved by 2. So we have a difference of a 3-word difference recalled on this type of test at the end of the trial. And on language, there's also a 1.3 word improvement as well on the KMCT group. Not shown here is also a significant improvement in the time taken, a reduction in the time taken to undertake the trail making test and the errors that were accumulated on that test. So there's 4 major areas that improved on KMCT. You'll notice that the number of people with a low score in the placebo group, this is a low score afterwards, so a delta score, were not present in the KMCT group. There's low performers on the episodic memory, there's low performers on the placebo for executive function, and there's low performers on the language tests for the placebo as well. So this is encouraging us to think that we can in fact correct a problem with the low performers, and that perhaps a prevention study would be appropriate to assess this in future. Critically, in terms of mechanism, we can show a relationship between the cognitive outcomes and the change in plasma ketones during this trial. So again, the delta performance, cognitive performance, is shown on the y-axis, and the delta in beta-hydroxybutyrate is shown on the x-axis. Blue is the keto MCT, the ketogenic MCT group, and the green circles are again the placebo. Clearly the placebo hangs around 0 in each of these cases, so there's no change in ketones on the placebo. There is an improvement in ketones in many of the participants on the KMCT arm, but not in everyone. Some people did not in fact change over time. Nevertheless, there's a significant positive relationship between the change in ketones and the cognitive performance on the episodic memory, executive function, and language tests, all to a significant extent. So this suggests that the more you can get ketones into the blood, the better chance you have of performing better on these cognitive domains. The 4th cognitive domain that I mentioned had also changed is illustrated in the next 2 slides. That is to say that in the white matter, people have never demonstrated changes in ketones before in white matter specifically, but we've done this analysis and just submitted it for publication, showing that the white matter takes up ketones, and the value corresponds to about a 20 micromole per gram per minute uptake rate. And once they've been on the KMCT, you can see that it goes from the bluish color to a strong yellow, with the endings of the tracks being in orange to red. So the tracks here go in all 3 dimensions. They go across the brain, and they go in the length of the brain, and from the deep areas to the cortical areas of the brain. But as you reach the endings, you can see that there are orange bits here. So in fact, we've increased the ketone uptake in these areas from about 20 to about 40 micromoles per gram per minute with the ketogenic MCT. And in so doing, we've been able to show that this increase across these different vesicles, these different tracks in the brain, also is associated with improved processing speed on these tests, which means the time that it takes to complete them goes down. So there's a strong correlation between improved processing speed and improved ketone uptake or energetics in these white matter tracks, especially in the fornix here, which is a deep central vesicle that is well known, and we're showing here for the first time the ketone uptake and the importance that it probably plays in these improvements in processing speed. So I mentioned a brain energy gap as being a central problem in the development of Alzheimer's disease, and I wanted to show these results graphically. If you take young healthy controls, their brain is running about 95% on ketones. So the 100% is based here on 95% from glucose and 5% from ketones in orange. Cognitively healthy older controls all seem to have a deficit in brain glucose on the order of about 11%, some of which is compensated for by ketones. So they definitely have a lower total brain energy uptake than in young healthy adults, despite the fact that they are performing normally on the cognitive tests. People with MCI have a further decline, particularly in glucose uptake. So the brain energy gap that we assessed in the BENEFIC trial was this difference between the uptake of both fuels in MCI compared to healthy young controls. So it's a gap of about 12% in MCI. When we give the 30 grams per day of the ketogenic MCT, we've reduced that gap to about 9%. So it's better, but it's not perfect. We could imagine that even if we went up by 50% with MCT, we would still not completely correct this brain energy gap. It would still be on the order of 6%. Nevertheless, with this improvement, we still see a cognitive benefit. So some degree of improvement is definitely associated with the cognitive improvement that we have been able to demonstrate. So in summary, in mild cognitive impairment, our ketogenic MCT drink increased blood and brain ketones over 6 months. It corrected or bypassed about a third of the brain energy gap in these individuals. Memory, executive function, and language and processing speed all improved. So 4 out of the 5 major cognitive domains all improved. So this is a general, broad-based benefit for cognition by providing more fuel in the form of ketones. With the memory effect and on executive function and language, there was a moderate effect size, which means that it's close to clinically relevant, and this suggests that we may be able to see benefits in a long-term trial. There's definitely a mechanistic link between the cognitive improvement and the increase in plasma and brain ketones in 4 of the cognitive domains. So providing more ketones, you get a dose-response relationship, which means if we could get a little bit higher plasma ketones and higher brain ketones, we would potentially have a better outcome for cognition. I haven't shown the data, but they're reported in our publications from Fortier et al. In 2019 and 2020, showing that the plasma metabolic and cardio safety profile is unchanged over 6 months. So these individuals did not gain weight. They did not have a deterioration in blood lipid profiles, insulin, triglycerides, body weight, body mass index, etc. There is no risk for taking 30 grams of KMCT per day, or in fact the placebo that was used. So our drink has been commercialized now by Nestle Health Science in the form of Brain Expert, which is available online, particularly in Europe. It's important to review briefly other ketogenic interventions that have been done in Alzheimer's disease and in people at risk of Alzheimer's disease, and they're reported in more detail in our review in Nature Reviews Drug Discovery last year. So other people have assessed Alzheimer's disease, they've assessed mild cognitive impairment like we have, also Alzheimer's trials and subjective memory complaints. They've used the the KMCT in the form of caprylic acid C8. They've used ketogenic diet. They've used C8 and C10, which we've studied. So there's a variety of approaches. Most of them have been small trials. Some have had cognition as an endpoint, but many have just been feasibility trials to try and get adapted the participants, the patients, and the researchers to figure out how to do this sort of research or to assess ketone status or brain energy status. So some people have assessed memory, and in most cases where memory was assessed, there was improvements. And in one case here, in Neth's study published in Neurobiology of Aging last year, there was an improvement in markers of neuropathology in cerebrospinal fluid. So this is a suggestion that maybe the improved energy status of the brain with ketones is actually helping to reduce the neuropathology associated with Alzheimer's disease as well. So in my view, the next steps we need to think about are we need to see confirmation, optimization of brain energy rescue with ketones. That means that we need to see other people doing these trials. Optimization means that we're starting a new trial with a ketone salt because it is more ketogenic for the same dose than medium chain triglyceride. So it should help optimize the effect on cognition. This is a trial that's just been funded by the Alzheimer's Association USA and Nestle Health Sciences supplying the ketone salt, which is D-beta hydroxybutyrate. We need other randomized controlled trials, other researchers involved, other sites, perhaps other targets, other approaches. Let's see how robust these data are that have been published. We need to assess efficacy and formulation. Could we make ketogenic interventions more efficacious with other nutrients, perhaps with omega-3 fatty acids? Could we make omega-3 fatty acids more effective with a ketogenic intervention at the same time? How do we formulate these products for long-term increased acceptability, practicality, and sustainability? A 6-month trial is an important achievement, but in the lifespan of someone at this age, you could still expect to live another 20 years. So this is a kind of treatment that if it's affecting fuel, that's going to have to be provided for the rest of that person's life. So what kind of supplement can we provide that would be acceptable for that period of time? I think it's time to think about planning a prevention trial. We know we've got better cognitive outcomes in mild cognitive impairment. The question now is, has this actually changed the course of the disease? And the only way to know that is to do it over a period of time in which you can look at the incidence of Alzheimer's disease and whether or not you've slowed that down. So this is a long-term trial is necessary, probably a multi-center trial for validity and also for practicality to recruit enough participants over the duration of such a study. Ultimately, I think we need something to supply ketones to achieve brain energy rescue, but I think we're going to need to reduce other risk factors for Alzheimer's disease, and to me, one of the most important is insulin resistance. So I want to talk about these ketogenic supplements and the importance of insulin resistance on the next slides. We've assessed the metabolic effects of C8, C10, and coconut oil in these two panels that are shown here and published these results. So we use a metabolic study day, an 8-hour metabolic study day in which we give a breakfast with 20 grams of the test oil, and then again at lunch we just give the 20 grams of the test oil with no meal. And this shows, first of all, that without a meal you get a stronger ketogenic response to the same dose, whether you're giving C10, a mixture of C8 and C10, or C8 alone. If you have a meal, you definitely dampen the effect on ketones. But it also shows here that coconut oil does not increase plasma ketones more than fasting over the period of 8 hours. So coconut oil may potentially have benefits in Alzheimer's disease, but it doesn't seem to be via a ketogenic effect. Likewise, for C8 and C12, for C12 and C14, which are not shown here, we saw no effect on plasma ketone levels in this type of study. Whether you look at the individual values or the areas under the curve, the higher the C8 content of the product, the higher the ketogenic effect, And as you add coconut oil, you dilute it, and you have very little effect of coconut oil on ketones. So different MCT products have different ratios of C8 and C10, and this is a problem for the consumer because it's not easy to evaluate the MCT content of the various products that are available. The other important point about Alzheimer's disease is that insulin resistance, I think, plays a critical role in the development of Alzheimer's disease, and we're showing here that this is independent of age. So mild insulin resistance does develop in older people, but we see it here in young women, 24 years old. They had a normal BMI, they had a mild deficit in working memory, and they had a problem with brain glucose metabolism on the order of 10% in both the temporal cortex and in the parietal cortex, areas that are typically affected in Alzheimer's disease. They also had a problem with glucose metabolism on the order of 14%, depending on the area of the frontal cortex that was affected, which was very typical of normal aging. So these individuals at 24 years old started to have a pattern of brain metabolism associated with aging, sort of like premature aging, which would presumably increase their risk of Alzheimer's disease. And in fact, they had a problem with working memory already. So at 24 years old, we are seeing markers of brain energy problems, brain energy deficit, that may respond to brain energy rescue, and that would be an antecedent probably of Alzheimer's disease. I'll take a moment here to detail some of the different avenues of brain metabolism where we would expect to see some benefit of brain energy rescue strategies. So at the top here, I'm showing in red intranasal insulin, which is one approach to improving brain glucose uptake that I haven't discussed here. Exercise also increases brain glucose uptake. It also increases ketones, and ketones can be produced from ketogenic diets or from ketogenic supplements. Ketones then get into the brain cells and into the mitochondria as glucose does via aerobic glycolysis, and they produce ATP. Ketones may have an anti-inflammatory protective benefit as well, and they may reduce reactive oxygen species that are produced during glycolysis. So this is one potential role that ketones can play. They also could protect against a major source of free radicals, which is the electron transport chain. Ketones seem to be involved in mitochondrial biogenesis as well. So a combination of strategies which involve perhaps improving brain access to insulin, perhaps via intranasal insulin, with exercise, with ketones. These are strategies that have multiple effects on brain metabolism, and there may well be drugs that are available that could help improve these steps as well. So brain energy rescue is not a ketone-specific concept. There are multiple elements to it. So I'll summarize my talk about brain energy rescue with ketones in Alzheimer's disease with the following points. It is clear that brain glucose specific deficit exists and contributes to Alzheimer's disease risk and a vicious cycle that develops as Alzheimer's disease progresses. It appears to be glucose specific. This is confirmed by gene expression studies that have been done that confirm our PET studies, a paper that's about to appear in Alzheimer's and dementia. So ketone metabolism seems to be intact, and it does help improve cognitive outcomes both in Alzheimer's disease and mild cognitive impairment. These cognitive improvements definitely need further evaluation in larger, longer, randomized controlled trials. They need to be randomized and placebo-controlled because cognitive evaluations are notoriously susceptible to subjective influences, and it's very important to avoid or at least dampen that effect as much as possible. Ketones may be able to reduce Alzheimer's neuropathology. There's a preliminary study that suggests this, published in Neurobiology of Aging last year, and if so, this would help undoubtedly with reducing the progression towards more severe Alzheimer's disease. One of the other elements that needs to be dealt with is a risk factor of insulin resistance and type 2 diabetes, in which brain glucose is definitely impaired and it is independent of age. So prevention, by definition, we want to try and prevent the disease from getting established, and that means people do all they can to reduce insulin resistance, and that involves perhaps a ketogenic supplement, but definitely exercise and other means of reducing insulin resistance, and perhaps other treatments as well. So brain energy rescue is a multimodal process. There's no magic in it. There's no miracle cures. There are components that need to be dealt with.
Okay, so Stefan, are you online? Thank you very much for the talk. Just a minute, I will stop my share screen and we can all see you. Actually, where are you? Here you are. Okay. Now you are pinned down. Now everybody sees you. So thank you very much for the talk. It was a pleasure. Very, very interesting and even exciting. I have a couple of questions for you from the audience. So the first question from Slava Berger, Dr. Slava Berger. What do you think about using MCT and ketosis for brain tumors?
So first of all, thank you for hosting this guy. What is it, Guy?
Guy.
It's a pleasure to have an opportunity to speak to people in Israel and to have an exchange with you. So thank you. Tumors. I'm not a specialist on cancer, but I do know that the ketogenic diet has been used successfully to treat brain tumors. So it has to be a severe form of ketogenic diet in which glucose is very limited in order to be successful. But I've met people that have had brain tumors and are raising their families. They're young adults raising their families, and they're obviously alive and they're doing well. And this is normally not going to happen.
Does this include glioblastomas? Does this include glioblastomas?
Yes, glioblastoma in particular, but I'm not a cancer specialist, so but I think there's considerable evidence now that this is probably an important way to treat these intractable forms of tumors, brain tumors.
Okay, good answer, Slava. I hope this answers what you're asking. Another question here from Chen. Did the people in your MCT research get a normal, standard carbohydrate diet, or was it a ketogenic diet?
Thank you for that question. Yes, they ate what they eat normally.
Okay.
So if some people didn't eat breakfast, we didn't make them eat breakfast. We didn't ask them to change their diets. They didn't gain weight, and they didn't have any sort of cardiovascular metabolic problems. So we don't think we changed their metabolic health, but they did not change what they ate.
Okay, that's great. So this is connected to another question that Gil is asking. So can we think of MCT as a good treatment when people are carbohydrate eaters? They are not fat eaters. They are not fat adapted. So you would see it as a good treatment even for these people without making them on a ketogenic diet, right?
So as far as we know, we've published some work showing that if you take a ketogenic diet or if you take a normal carbohydrate intake of at least 50% of energy, you still get the same increase in ketones after MCT. So this is independent of your fat intake. It's independent of your carbohydrate intake. Okay. However, if you take no food, you have a stronger effect on ketones than if you take either a fat or some kind of mixed meal. So taking the MCT on an empty stomach will give you a stronger ketone effect, but maybe more side effects and discomfort in the abdomen.
I can tell you that I can tell you that we have many reactions. Even I know it for myself. If I take 30 grams of MCT on an empty stomach, it goes down the toilet. So it's hard to hold this without any food. It's
Right.
a task. What type of food would you take it in order to stop that and still get the benefit on ketones? So if I can't hold 30 grams in one shot.
Well, we don't give 30 grams at a time. We give it usually as 2 doses. That's the first point. We emulsify it. It's emulsified. We use milk, which was simple, but some people don't eat cow's milk. So this we need to find some other way to emulsify it. So a good emulsification, kind of dilution in a way, in the volume, will help. But some people are very resistant anyway. So you are maybe more sensitive and some other people are more sensitive and some people don't notice a problem at all.
So just try.
Is it the microbiome? Yeah, you have to try it and see, and to start with small doses and build up slowly.
There is a question here from Alisa. You may know her because she studied in your seminar in England, in the UK a year ago.
Maybe if I can see her picture.
She's here, yeah. I think her video is on.
Hi, Stefan. It was a great talk. Thank you.
I'm looking for your image, but I don't see it. There's so many people online.
Yeah, there are many people here. So she's asking, do you think there is a maximum value for ketone brain uptake, which is not only dose dependent? Or the higher you go in your, or the higher you go in your blood, the more will go into the brain?
Yeah, as far as we know, it's a very strong linear relationship, which means higher you consume, more is getting into the brain. We haven't studied this with MCT, but if you look during people who have been fasting for very long periods of time have very high plasma ketones and very high contribution to the brain energy metabolism. So it looks linear over a large range.
Okay, so if people suffer from dementia, you would tell them do it for a long time and get the improvement over a long time, everyday high ketones.
Potentially. The problem is if too many brain cells have died, it may be impossible to recover the brain function after a certain period of time.
Yeah. Okay.
So this is unknown.
Okay, another question, if ketones are similar to fasting, what is your opinion about fasting and intermittent fasting as a treatment for dementia? Would you recommend it?
I think everybody has to do this the way that they like the most for themselves. I don't think too many older people, especially in a nursing home or in a residence, are going to want to do intermittent fasting. Most of them don't want to change their diet very much, at least in Canada. So if it works for you, intermittent fasting has become popular, but it's mostly young adults with a very high level of motivation who are doing this. And no problem. I don't think there's any medical risk associated with it. But I don't think it's going to be a long-term solution to treating Alzheimer's disease.
Okay, so actually it's a good preventative measure, probably. That's what you're saying.
It's a component that you can add, and it's going to make the ketones more effective without the carbohydrate or the insulin around. So there will be some advantages, but you have to do it in a sustainable way. It's not for 2 weeks.
I'm doing intermittent fasting for 5 years, so it works great for me.
Well, that's great.
I'm 61. It works for me
maybe
and for
it's
my
contributing
wife.
To you to being healthy.
I have another question for you, and it's related to the MCT oil that's available in Israel on the market. We are launching this product, a keto oil, we call it. It's a 60% C8, 40% C10, which is pretty similar to what you used in your experiment, or maybe it's the same even. Now, what do you think of it as a cooking oil, as an edible oil, not as a supplement?
It's never been recommended for this purpose, but I don't think there's any problem as long as the cooking is relatively short. If you're doing this for 10 to 15 minutes, I think there's no problem. If you're trying to deep fry something for 40 minutes, or it stays hot for, there's probably maybe some degradation, but
maybe you want to ask Alisa, you're a student here, and she's my R&D, she's in charge of R&D, to send you her results on over a study about the fantastic, we just showed it, she showed just before you, maybe you saw the last minutes of her talk, she showed the oxidation parameters of MCT under deep frying, 200 degrees for 20 minutes, and it's extremely stable. You don't get peroxides and aldehydes. And actually, she compared it to olive oil and canola, and we showed this. And the olive oil and canola go very high, and this stays low. And by the way, she's going to do a larger experiment comparing soy and corn and sunflower oils, all the omega-6 oils, in deep frying to MCT. So if it's interesting, she will gladly share with you.
Of course. I think even if it's safe, I'm not sure it's going to produce much ketones, because maybe a meal prepared this way will give you 5 or 6 or maybe 10 grams of MCT at the most.
Yes.
So it's one way to do it. And some people will enjoy it this way. Some people would prefer to make some kind of drink, and each person has their own choice.
Do you know what falafel is? Have you heard of falafel?
Yes.
So
sure.
we actually made falafel with keto oil, 30 minutes, 7 rounds of deep frying, and it came out perfect. And we actually tested the oxidation after. There was some oxidation, but much below the limit. Okay, there are a few more questions coming up. I want to really let people ask. Just a second. Okay, does a high insulin level in the blood affect the efficiency of MCT, for example, on type 1 diabetes persons? How do you see that? Or does it work?
All we know, we published a paper in pre-diabetics. So this is not a high level of insulin, but it's elevated above normal. And the response to 10 grams of MCT was exactly the same as in someone without insulin, raised insulin levels. So we think that you can get pretty much the same effect. Maybe not exactly the same, but not bad. It still would be beneficial to reduce the insulin resistance, that's for sure.
I know from Mariella Gallant that there's a doctor in Israel that's treating, she has a diabetic, Dr. Gallant, she has a diabetic clinic, and she's taken type 1 diabetics from 30 portions of insulin down to maybe 3 or 5 a day. So it works very well. I don't know if she uses MCT, she uses ketogenic diet. So it works, the ketogenic diet works for that. I'm not sure if she uses MCT, maybe yes. Okay, we don't have any more questions. You've answered my curiosity. So thank you very much for coming to us all the way from Canada. I hope you enjoyed our questions and being with us. And thank you very much. And I will go to the next presenter, Amit Ben Adiri. She's the head of the Naturopaths in organization in Israel, and she's going to talk to us in Hebrew, unfortunately, about treating patients with MCT.
Okay,
well, thank you for again. And
Stefan, thank you for every word. I just took everything. I wrote everything. I'm going to listen again and again and again, and probably I'm going to meet you soon.
Well, thank you very much, all of you. And if you have some further questions, you can send them to Guy, and we can discuss it some more.
Yeah, sure. People send questions to me. I'll forward them to Stefan. Okay, Amit.
Enjoy your webinar, and thank you so much.
Thank you very much.